is a tool? Do you think you know? Or did my new question trip you up? Yeah? What do you think, Zaria? A spoon is another type of tool. What do you think?
A tool is like a thing that you could use to like repair something.
To repair something? So basically a tool is something that helps us solve a problem or fix something. It helps us in any way, right? So an example of a tool would be a screwdriver or a spoon or tweezers, or even our hands can be tools. Pencils are tools. They help us to write. So anything can be a tool as long as it helps us to achieve something, okay? So we're going to talk today about using the right tool to separate mixtures. So how to separate them in different ways and what we use to separate them, okay? Our goal of the day. Our goal of the day is to explore and identify how to separate mixtures based on observable properties such as size, shape, color, and magnetic attraction. So remember, our observable properties are things that we can see, okay? Turn and tell the person sitting next to you what we're doing today. What's our goal? What do we want to achieve? Tell the person next to you. Are you telling the ghost sitting next to you? Okay. Dobby, can you tell me what we're doing today?
We're going to identify how to separate mixtures by size, shape.
Very good. We're identifying how to separate mixtures on size, shape, and color. Isaac, are you back with us?
Yeah.
Okay, so we just talked about this. You guys just reminded me that our mixtures are combinations of two or more substances that can be easily separated. That's going to be our main focus for learning how to separate mixtures, because separating solutions is much more difficult, and there's only a few ways you can separate a solution, but there's many ways that you can separate a mixture, okay? So I have some examples down here of some mixtures. And this one specifically tripped us up last time when we were doing our independent work. And the question was, is sand and water a solution? And lots of friends were saying yes. But I think you're just getting confused with water and sand and water and salt. Because if you mix salt into water, it's going to dissolve. But if you mix sand into water, it's just like going to the beach. When you go to the beach, you can feel the sand on the floor, right? Yeah. It's not mixed into the water, but you can't feel the salt in the water, right? So just think of the beach. Salt and water, solution. Water and sand, mixtures, okay? So that's why I specifically chose that picture. And then down here I have substances or mixtures where one substance has dissolved in another, okay? Okay, so these are the observable properties we're talking about. There are also other properties like weight and density and all those things, but our observable properties are size, color, shape, and magnetic attraction, okay? So something that has a magnetic attraction means that you can take a magnet and it will come to the magnet, okay? Like metal.
Iron?
Yep, like metal, steel, iron. You can separate things by shape. If I have a bunch of rectangles and a bunch of squares all mixed together, I can separate all the squares together and all the rectangles together. You could separate by color. Let's use these marbles I have up here. For example, I could take all these yellow marbles and separate just the yellow, right? And then size is the same as, like, if I had a bunch of rectangles and a bunch of squares. Rectangles are typically larger than squares. I could put all the squares to the side and all the rectangles to the side. Okay? Is what?
Is that edible?
The marbles? No. They're not gumballs. I heard somebody say that earlier.
M&Ms.
They're marbles.
Like peanuts.
They're marbles. So they're not edible. What was your question, Sarah?
We never got our mixtures and solution paper. The one that you gave us.
You never got it? The one I gave you?
Yeah, like
If I gave it to you, how did you not get it?
no, like didn't you grade it? Or something?
Oh, I don't think that we finished that yet. I think that was what was one of these papers on
Oh.
here. Yeah. Okay, types of separations. I also have this in a nice handy poster board, but I'm going to put it right here for us to look at, okay? Let's see if it will stay up. Okay, mixtures can be separated by using a variety of tools in a variety of ways. Knowing the physical properties of a mixture can help to determine the best tool for the job. So knowing that marbles are different colors, right? We need to know our colors. Our dogs can only see certain colors, right? So a dog is not going to be able to separate things by color like we can. So you need to know colors. You need to know if something is large or small, okay? You need to know if something has magnetic attraction. It's not always easy to know if something has magnetic attraction. Like, everyone can look over at what Isaac is doing right now. He's putting his eraser on his board because inside the eraser is a magnet, and whiteboards have magnetic attraction, just like these papers are held up by magnets, okay? The best way to know if something has magnetic attraction is really to put a magnet on it. That's the best way. Or try to stick it to your fridge.
Oh yeah, I have a lot.
But we know that most metal and steel and iron are magnetic, okay? So the types of separation, like I have on my poster, are evaporation, sieving, filtration, magnets, hand tools, and floating, okay? Now we're going to talk about tools within these types of separations, okay? So, for evaporation, most of the time you're using heat, okay? So if I had salt and water mixed together, that is a solution. It's much more difficult to separate. That's not going to be one of the examples we try today because it's a little bit dangerous. I'm not going to give you guys heat or fire. But if you boiled salt water, eventually the water would all evaporate and you'd be left with just the salt and they'd be separated. Okay? So evaporation, you'd use heat. For filtration, you'd use a filter. Think of coffee. When you make coffee, you mix together water and coffee beans, okay? And you put it in a filter, and the water comes down, and all that liquid that tastes like coffee now, because of those coffee beans, is separate from the beans, okay? So for filtration, you're using filters. That one's pretty easy to remember. Filtration, filters. For sieving, you can use a sieve, which looks like this. It can look like a lot of different ways, but most of the time it looks like this. It's a wire with small holes, okay? So you're going to separate things that are different sizes with this type. If you have something very small and you have something larger, you can put it in a sieve or a strainer or a sifter. A sifter is the round ones that you take to the beach when you're a kid, maybe, and you shake them, and then rocks stay in and the sand falls out. Those are all sieving separations. And then you have magnets. You can use a wand, a regular magnet. You could even use these little magnets. Any type of magnet to get iron or steel out of some sort of mixture. Some more tools. For floating, you use water. We'll do a floating demonstration here before you guys get to do lots of experimenting later. Put that away. And then we have hand tools. So, the most obvious hand tool is your hands. Your hands. You can use your hands to separate things like I was doing with the marbles. I'm separating it with my fingers. Or, I could use a spoon. Or I could use tweezers. Lots of things. Anything I use with my hands is a hand tool. Okay? I'm going to set this back here so it's out of our way. Alright, we're going to do a little experiment. So if everyone can make sure their eyes are on the front so they can see, I'm going to make a mixture. And over on the table over there when you're doing your skill, there are already some mixtures created for you. But I'm going to mix this up. I'm not going to shake it too hard because they're glass. just want them to be all pretty mixed together. Okay. Now, I know that I could separate it by color, but some of my marbles are also white, so that wouldn't really be the best way to separate these. I could separate it by hand, but there's so many pieces that would maybe take a while. So, another thing I know about marshmallows and marbles is that marshmallows are very light and marbles are heavy. They're not super heavy, but they're heavier than marshmallows. So, I'm going to use floating.
Oh.
And I'm going to pour my water into my jar and hopefully not spill. And then my marshmallows are going to rise. And it looks like cloudy like that because marshmallows have sugar coating. But all my marbles that are heavy stayed on the bottom and all my marshmallows came to the top. What's the best tool to get the marshmallows out now?
A spoon?
A spoon? What kind of spoon?
One of those that have a hole in the bottom.
Why the one with the hole?
Because you want to drain the water.
Because you want to drain the water. Because if I take it out with this spoon, then I still kind of have a mixture of water and marshmallows now, right? All right, let me take all of these marshmallows out so we can do one more separation. Because in separating this mixture, I also created another mixture. What's my mixture now?
Sugary water.
Water and
Sugar.
marbles.
Smart water.
So, if we're looking at my tool, all my tools and all my types of separations, we have water and marbles. So, is evaporation the best way to go?
No.
No. Is filtration the best way to go?
No.
No, maybe. Are hand tools the best way to go?
Yes.
Maybe. Is flotation the best way to go?
No.
For water and marbles? Is magnetism?
No.
What about sieving?
Yes.
Okay, so we could do sieving or filtration or hand tools. Okay? We could use a spoon with holes in it. I could easily scoop these out. Or I could put a coffee filter and I could pour the water and wait for the water to all drip through. Or I could use a sieve/strainer and pour all the water back in here. And now it's separated. Okay? Alrighty. That is our demonstration. Alright, we're not going just yet, but I want to tell you what we're doing today. I'm going to give you three papers, okay? The first paper has some pictures on it of different types of tools, when those tools are useful, and